Welcome back to another video, and this time we are going to continue on UVM, and this time I will go through one of the UVM service mechanism, and specifically UVM factory. So UVM factory provides a lot of uh, macros and some service mechanism which can be used during the runtime and uh, later in the upper level of hierarchy of the code. So in this class, we are going to discuss about the factory override method. And factory override method is, in simple words, it is just a method which has the ability of replacing a certain class with another class, and it can be done globally, which means that if you use that method, which is the global one, and if you use to suppose there are two classes, let's say class 1 and class 2, and using the global method, if you replace the class 1 with the class 2, then that instance, wherever you have instantiated the class 1, it will get replaced all over the UVM environment with class 2. And same goes with the other method. And uh, there is one more method which is replacing locally or replacing the instance. So in that particular method, you have one more argument in which you can mention the hierarchy. And in that particular hierarchy which is mentioned, in that hierarchy, all the instance of that class will be replaced with the one you are replacing with. So without any further boring details, let's begin with the practical. And this is the same UVM environment test bench that I've used in my earlier lectures. So please refer to my earlier lecture in which I have designed a very simple adder. And just for the sake of simplicity, I created every component and object very simple. So you can see that inside my transaction or the sequence item class, I don't have any constraints. So just for the sake of simplicity, I created the components and the objects very simple. So please go and refer to that videos. And what I will do, I will use the factory override method inside the test class. And I will be using both of the factory override method. So the first one is the global one, which whenever it is used, it will override every instance of that class with the another class. So let's begin. So I will use that particular method inside the build phase of the class, and to use that, you have to just write set underscore type underscore override by type. And after writing this method will have two arguments. And the first argument will be the type of the class which you want to replace. And the second argument will be the type of the class uh, to which you want to replace the class with. So let's say in our case, just hold on. So let's say I want to replace the sequence, the sequence class. The name of the sequence class is sequence one with another sequence, and it will be a dummy sequence with different values. And it is not our major concern that whether we are providing the intended stimulus or not. So if I want to replace this with another sequence class, I can simply do that globally by using this particular method. But before that, let's create another sequence class. So what I will do, I will just go ahead and just create new file, and let's call it sequence 2. Let's open it and let's make it uh, let's make it derived from the sequence class so that we don't have to mention this and that. So it will consist it will have the properties and the methods of the sequence class, and in top of that we will add few more stuff. I will call it sequence 2 and it extends the sequence 1 class. So the first thing we will do is, of course, we will uh, do the factory registration. And since sequence is an object, we will use UVM object utils. And it's a macro, so do not you should not use the semicolon. It's a bad idea. So inside this, I will write the name of the class. And the very first thing we will do is to write the constructor and then call the constructor of the parent class. And this constructor will have only one argument since it is an object, and that argument will be a string name, and I will name it same as the name of the class. And inside this, since the constructor of the parent class has some formal arguments, you have to explicitly call the constructor of the parent class, otherwise you will get a compilation error. So we are done with this. So we will move on to the next thing in the sequence, which is the virtual task body, where we will provide the stimulus to the sequencer, then it will get passed to the driver, and then driver will drive it to the DUT. So the very first thing we are going to do is we will just create uh, the object for the transaction class. Here you will see that I haven't mentioned any handle for the transaction class because sequence 2 is derived from sequence 1, and the sequence 1 already has the handle of the transaction class mentioned. So we will just go ahead and create um, the object, assign the object to this handle using the type ID create method. So name of the transaction class was sequence item. Let me show it to you. Yeah, it was sequence item. It will have only one argument, and I will write it T, the name of the handle. So right after doing this, we will begin with the start item and the finish item. And both start item and finish item method should have the transaction as an formal argument. Also, you should put it inside a repeat block just to repeat so that you can calibrate that how many times you want the randomization or how many transactions you want to send to the DUT. So in our sequence class, I sent the transaction for 10 times. And since our major aim in this video is to replace the sequence 1 with sequence 2, I'm going to just repeat it for 2 times, just for the simplicity's sake. and we will move it inside the repeat block. And inside the start item and the finish item, we are going to randomize our transaction. So let's just randomize it. And this time, just to make it different from the sequence class, we will randomize it with certain values, and it can be anything. And just for this example, let's say using the with method, let's say I want the value of a to be 0 and also the value of b equals to 0, which sounds kind of stupid because as an adder, this will output 0 and every transaction is going to be same, and there are two transactions in total, by the way. But it is not our major concern. Our major concern is to replace the sequence 1 successfully with sequence 2 using the uh, using the factory override method. So after writing this, uh, we just have to write the semicolon. But before that, since the randomize method has a return type, and here we like uh, we are not getting any value, so we will just to avoid warnings, we will just dynamic cast it using the void. So the return type will automatically become void. So it's not a necessary step, but it will just reduce the clutter. So after this, we can do lots of things. So let's just make it very simple, and let's write a UVM info macro. And inside this, the very first thing I will do is to get the type name as a string, which will work as a type ID. And the second argument is going to be a message. And I will keep the message very simple. The following transaction is being sent from the sequence 2, just to indicate that, just to get an idea whether the sequence 2 has replaced the sequence 1 or not. And also we have to write the third argument, which is the verbosity. And let's make it simple. We will be using UVM none. We can also use UVM medium, it will work because by default the verbosity is UVM medium. And just remember, with macros, avoid using semicolon. So let's just add one more thing. And since in our transaction or sequence item class, we have registered every variables using the UVM object utils begin, we could use the various methods of printing the transaction in tabular form, and the most commonly used one is print. So it will just print the values, the signals in a tabular form, which is very convenient while checking uh, the test cases using the transcript. So that's all. So first, let's check whether I have made any typo or we run into any compilation error. And by the way, let's label this also. It's not necessary, but I like to label it. So I will open the QuestaSIm. Okay. So of course I need to create a new project which will be pointing towards this directory. and it's UVM, and make it UVM. Okay, it will replace that project, and let's add the existing top level file because we have included everything inside the top level file. So compiling it will result in compiling everything. And yes, before that, we need to include that particular sequence inside our package. So let's find out our package where we have made all the instantiation. Yeah. So generally people will use the .svh format for package, but here in our example it does not matter. And just remember that the order in which you are including the file matters a lot because that's how, I mean, it is the order how every file will get compiled. And in case of compilation, you definitely want the bottom level components or objects to be compiled before the top level one. That is, you want driver or monitor to be compiled before agent because the driver and monitor are subset of agent. So make sure of that. And here in our case, we have created new file called sequence2 and we will include it right after the sequence. I mean, since we are using, we are mentioning everything inside the test class and we are replacing the type inside the test class, we should mention it before the test class. So all right. So everything is done. Let's get back to our test class. So here, our aim is to replace the class sequence 1 with the sequence 2. Note here, it does not matter that whether you have created the handle of sequence 2 or not. You could just directly refer to that particular class in the hierarchy using this particular method. And here you can see that we are using the handle of the sequence 1 to start the sequencer, and we are not using sequence 2. But without even writing or creating an object for the sequence 2, our aim is that to replace every instance of the sequence 1 with sequence 2. So even though we have mentioned sequence 1 here, sequence 2 will get executed. So let's use this method. Uh, it's called factory override, and this particular one is global override or override by type. So to use that, our first argument should be the class which will be overridden. So that class is sequence 1. And then using the scope resolution operator, you need to write the get type method. So get type method, as the name sound, it will return the type of that particular class. So this is our first argument. Similarly, our second argument will be the class from which you want to replace the sequence 1 class. So here I will write sequence 2. And similarly, just like our previous argument, here we have to use the scope resolution operator, and then again we have to use the get type method. So this concludes our global override, and let's see whether we have any compilation errors or not. Okay, we did run into a single error. Okay, it says that I've written something wrong in the sequence 2, the line number 13, near equals to. Okay, let's see. Uh, this is sequence 2 and line number 13. Oh, yeah. When we are using the with clause method and we are assigning some values um, to the variables for that packet, we need to use two assignment operator, not just a single assignment operator. Let's see whether it has resolved the error or not. Okay, it has resolved the error, but there's a warning written. All right, something. So let's just go ahead and run the simulation and also check whether we run into any runtime simulation error or not. Okay, let's check what is happening here. So as you can see that instead of getting sequence 1, we are getting sequence 2. And as I've already mentioned that for our sequence 2, we only sent two transactions, two randomized transactions, and those are actually not randomized because we are constraining the values to be 0 and 0 for both the possible inputs. So we have only two packets, and in the case of our original sequence 1 class, we had 10 packets. So it has replaced the sequence 1. You can see that we have only two complete transactions. You can see that the first transaction occurred here, that sequence 2. The following transaction is being sent from the sequence 2 class. And it is the same UVM info macro which was mentioned inside the sequence 2 class. And you can just get the idea of the type ID. And after that, the checks happen. The data packet goes to driver, then it goes to monitor from the duty, and then it goes to the scoreboard and test pass. And then the second repetition occurs here, and the same thing happens. So you can see that we are running the same test class, and in this test class we don't have any handle of the sequence 2 class. And even here inside the phase raise objection and drop objection, we are starting the sequencer using the handle of the sequence 1, but it is now working as the handle of the sequence 2 class because we have used just this simple line, the factory override method, which basically uh, replaced every instantiation of the sequence 1 class with sequence 2 class globally, all around, everywhere in the environment. So that was a very simple example of global override by type, and you can use this to do a lot of stuff like replacing a faulty agent with the new one or the updated one. You can do a lots of things, and it can just reduce the debugging efforts and other things very easily. You don't have to uh, customize or go through the entire code to debug something. Instead, you can just write a new class and you can include it inside the package, and then in the top level component like UVM test, you could just replace that particular class or instance of that class globally. So we are done with this. So let's move on to our next overriding type, which is not global, and it has one additional argument at the beginning, and that argument is nothing. It is just the hierarchy or just the path in which you want to replace, in which you want this replacement to happen. And that way of writing the hierarchy is very similar to that of you could find inside the UVM configuration DB. So let's begin with this. So the next one is the override by instance. And to write that, you just have to write set instant instance. So you just have to write the abbreviated form inst instance. Then the same thing, override underscore override by type. So here you will have three arguments. The last two arguments will be the same, and the first argument will be the relative path. So I don't think that sequence will be an ideal case for this one. So for this example, what I will do, I will create a faulty driver, and I will replace our original driver, which is here. So I will replace this original driver at the agent hierarchy. So inside the agent, we have driver, we have sequencer. So at that particular hierarchy, I will replace that. And we also have monitor, by the way. So I will replace that with the faulty driver. And since we have already mentioned this particular driver in the upper level of hierarchy, because I will be applying that override to the agent class, and we have already mentioned the instantiation in the upper level class, it will show an error. And also that driver will be almost null. It will have nothing inside its run phase. So let's begin. So let's just go ahead and create another driver class. I will create a new SV file for that. Let's call it similar to sequence 2. Let's call it driver 2, and the extension should be SV. All right. Yeah, so we have driver 2, and let's just create this class. And this will not be derived from driver, it will be fully independent. So it should extend the UVM driver, and UVM driver has the transaction class as an argument, and the name of our transaction class is sequence item. So let's do the factory registration. And since this is not an object, it is a component, we will write UVM component utils. And this is the macro. Again, you don't have to write the semicolon, otherwise you will run into some errors and it will be very hard to debug. So let's write the constructor. And since this is a component, it will have two arguments. The first one should be a string. I will call it name, and I will write the same name. And the second argument is going to be of type UVM component, which is inbuilt type of the UVM libraries. And then I will name the instance of this as parent, and I will give it null. Very first thing we are going to do is to call the constructor of the parent class, because the parent class has the constructor of the parent class has formal arguments, so you have to call it explicitly. We will have two arguments, name and parent. And also here, since it is independent from the driver class, we will have to mention the sequence item, the handle of the sequence item or the transaction class. We will name it as t, and then we will mention it inside the build phase. And every phase have only one simple argument, UVM phase of type UVM phase, and that argument is phase. Very first thing is to call the parents constructor explicitly, and it will have any simple argument phase, and this will not be super.new, it should be super.build phase. So first I will create the object for the transaction class using the create method. And the second most important thing that we do in the driver is to write the name of the interface, and it declares it as a virtual interface. So the name of our interface was addIF, and we have to declare it as virtual interface. Then we have to use the get method of the UVM configuration DB. That configuration DB will get the database of this interface from the top level class, where we are using the set method to put that interface inside the configuration database. So let's do it. Oh, the test class. Okay, so our driver 2 is right here, and again the name of our interface was add underscore if. So right after sequence I will write virtual, and let's call it VIF. So now we will write a conditional statement to confirm whether we are able to retrieve the interface from the database or not. Otherwise, it will show an error. And of course, never use any system task in your UVM test bench. Always use the provided macros from the libraries because they have lots of advantages over them. So if UVM config underscore db, and it will first have the argument that what is the type of the data you want to retrieve from the database, and the type is address underscore if. But since we have declared it as a virtual, and we have to obviously get the virtual type, because by default interface is not a virtual construct, so you will add virtual right here. And then after that, using the scope resolution operator, we will write get, and then after that it will have 4 arguments. So the first argument is going to be the uh, the the path where this particular get method belongs to, and I will just write this that it belongs to this particular driver2 class. The second argument, which is written using the string in string format, is the relative path, which basically means that what is the scope of this particular get method, and it is visible to what other class. I will just leave it as it is, so it will be null. So it is only visible to this particular class. And then the third argument will again be a string, and that is going to be your user defined name, which is very similar to this. So I will just write VIF, which is the handle name which I have declared right here, or the instance name of the interface. Then the last argument will be the handle you are referring to, or the instance you are referring to. Why I'm saying handle, it's not a class. So it's VIF. So I will write VIF. So if it is successful in retrieving, then it's all good. Otherwise, it will show an error. So we will add a UVM error macro. And unlike UVM info, all the other macros have only two arguments. The first argument is the ID, which I will retrieve using the get type name method. And the second argument, it will be the message. I will write the simple thing, failed to access the, not the, and don't write a semicolon right here. So we are done with the build phase of our driver. So let's begin with the run phase. And we have to just keep it blank. Anyways, I will write something just to avoid running into any runtime or compilation error. So inside the run phase, we will write a forever loop, a forever block. And here we will use the sequence item port, which maintains the communication with the sequence item export of the UVM sequencer. And the first method will be get next item, which will request the buffer which is present inside the sequence for new transaction, and I will explain this in details in my upcoming lectures, so don't worry. So this particular thing, since it is sending the transaction and driving the transaction to the DUT, it should have an argument, and that argument is going to be our transaction. And the second thing, just to end this sequence item port, this method is item done. An item done is just a feedback that is sent to the sequencer, then from sequencer to uh, the the sequence, so that sequence can start another transaction using the start item. So since it is not returning any transaction, it is just a response. You do not need any argument, and it does not have any argument, by the way. So after this, since our major aim was to replace the major driver with this dummy driver, we will stop here, and first we will go ahead and check for any typos or any possible compilation error. So let me check it. I believe it should be fine. Oh yeah, the very first thing we are going to do is to include this right after the driver, so that it got compiled before the test. So let's go ahead and let's go ahead and compile the top level file. Okay, we did run into some errors uh, in driver 2, UVM phase of virtual method. Okay, let's see. We will go with the beginning line. Oh, it should be uh, just a second. Oh, I just dropped the I didn't even finish the override method. What I am doing? Yeah, we have to complete this particular method. But still, I think we have some errors in sequence file. For before that, let's just finish this. So here we will have three arguments, and the very first argument is going to be the relative path where you want this overriding to take place. So we want the hierarchy under the agent class. So let's refer to the agent class. So, and our very first argument, the path, the relative path should be written as a string. So let's say the instance of the environment class is E, and what is the instance of the agent class in the environment class? Let's find out. So here inside the environment class, the handle or the instance of the agent class we have written as A. So we will refer to A. And then we will do the same thing. So first class is going to be the class which will get replaced. And then using the scope resolution operator, we will get the type, not the type name. And the second class is going to be the driver2 class, which we will replace the driver class. And that concludes our type override by instance. So even though it will successfully replace everything with driver2, it should show an error that uh, that we are, even though driver1 is in the hierarchy, uh, the driver1 the instance of driver1 inside the agent is getting replaced with driver2. So let's just run the compilation again. Let's check what's going on. Okay, we do have 4 errors. Let's find out. Okay, let's go to the line number 22 of our driver2 class. Oh my god, here I should write face. It's a typo and I forgot to write it. I was in a hurry for something. And let's run the compilation check again. Oh, it was all. So let's see if we run into any runtime error. So let's just run the code. Okay, let's see what is happening inside our transcript. Okay, I think I just made one more mistake. I should use the star while mentioning this here. So it ensures that anything under the hierarchy of the agent, this override will get applied, because it didn't get applied because I didn't use star, and uh, because of that reason it was only looking at the agent class. But right now it will look down anything under the agent class, and inside the agent we have driver, sequencer, and the monitor. So let's see, it should work this time. We will go ahead and compile the code for one more time. Compilation is successful, so let's just run the code. Yep, we get a fatal. So that means that our intended functionality is successful. So let's read what is happening right here in the transcript. Factory did not return a component of type driver, which was our primary driver. A component of type driver2 was returned instead. And name is equals to D, parent is equals to agent, yada yada, and which basically resulted in the fatal. And that was our intention, that to replace the driver with the driver2, even though it caused a fatal, but we successfully replaced the instance of the driver class with driver2, and that too under the hierarchy of agent. So these are two of the important factory overrides method. The one is used to override the every instance of that particular class globally throughout the entire UVM environment. And the second one, that is instant override by type, is used to override the instances of that particular class with another class for a certain level of hierarchy. So I will continue this video series with more UVM features. So stay tuned for more. Thank you so much.